Good morning, grade 12s. Today we are going to do the topic chemical equilibrium. And this topic is found in your paper 2 and is probably going to be your question 6. What is it that you are expected to know? You are expected to explain what is meant by an open or a closed system. You are expected to define a reversible reaction. You are expected to define. Please, grade 12, this definition, I've lost count how many times it has been in a paper, and learners keep on making mistakes on how to define it. How do we define chemical equilibrium? We define chemical equilibrium as when the rate of the forward reaction is equal to the rate of the reverse reaction. What does that mean? It means when you reach equilibrium, it means the rate of the forward reaction is equal to the rate of reverse reaction. Remember, the word rate, we have done it when we were dealing with the concept rate of reaction. So you are familiar with how to define the word rate. But in this case, we are going now to concentrate on the equilibrium. So in order for the equilibrium to be reached, the system must be in a closed system. What does that mean? It means there won't be any interaction with the surrounding. That is when the equilibrium is going to be reached. We are also going to list the factors that influence the position of equilibrium. In the examination, they will not ask you to list. In the examination, they expect you to explain how these factors, pressure, concentration, and temperature, affects the position of the equilibrium. Equilibrium constant. This equilibrium constant, we normally call it Kc in the examination. So this was the topic that previously was done in the higher grade. When the introduction of the caps, this topic now is done in physical science paper 2. What is it that you are expected to know under equilibrium constant? You are expected, like I said, to list the factors that affect Kc. You are also expected to write down the Kc expression. It is very important. You cannot calculate Kc without knowing how to write the Kc expression. It means Kc expression serves as the formula for calculating the Kc. And in an examination, if you look at your previous question papers, you will find that this question, roughly, it's normally between 7 to 9 marks, which is very important. And in order for you to get all marks, you must start by getting the correct Kc expression. Once your Kc expression is correct, it means you can be able to calculate. What do? You perform calculations. And once you have calculated the value of the Kc, you must be able to explain what does a high value and a low value of equilibrium constant mean. It's very important. This question of the explanation of the Kc, you are normally going to find it mostly in the multiple choice question. So for you to be able to know, and you need to know, in order for you to explain the Kc expression, you need to know what are those factors that affects the Kc. The application. In the objective, we indicated to you that you are expected to know how does these factors affect the equilibrium, the position of the equilibrium. And first, you must be able to state the Liturginous principle. How do we state the Liturginous principle? It states that the equilibrium in a closed system. Remember, I explained to you that in order for the equilibrium to be reached, the system must be closed. It's disturbed. What does that mean? Something has been done to the equilibrium. What happens? The system will reinstate. In a normal situation, when somebody has made you angry, what do? You try to do something that will make you to become normal. So that is the same thing that is happening in the Liturginous principle, is that if the equilibrium is disturbed, what is going to happen? The system will try to reinstate the new equilibrium by favoring the reaction that opposes the disturbance. What does that mean? It means if somebody has disturbed you, you are not going to go to that person again in order for that person to make you happy. You need to change the position and go to other person that will try to reinstate your equilibrium so that you can be in a normal position. You are also going to use this principle to explain the changes, which is the position of the equilibrium. You are also expected to interpret the graph, and you also have to explain the rate of equilibrium principle, the Haber process. That is the process that you have done when you were doing fertilizers. So you will be expected to explain those reactions using Liturginous principle by applying those factors that affect the chemical equilibrium. Now, let's start with our lesson. I said at your objective, you must be able to explain or to define what is an open and a closed system. An open system is a system whereby there's a continuous interaction with the environment. What does that mean? It means either the reactants or the product may enter or leave the reaction in the container, which will make it impossible for that reaction to reach equilibrium, because something is getting out, something is getting in, and as a result, the equilibrium, the reaction has been disturbed. Closed system. Grade 12, remember, in order for the equilibrium to be reached, the system must be closed. Why must the system be closed? So that it's being isolated from the surrounding. Once you isolate it from the surrounding, it means nothing will be allowed to enter or leave the system. So whatever you have in the system is contained. So that is when the state of equilibrium will be able to be reached. Now, these are the types of reaction. You have got irreversible reaction. You have got reversible reaction. What is irreversible reaction? Irreversible reaction, it means the reaction is occurring in one direction. Let's take, for instance, you have got this hypothetical reaction, A plus B. So this one is irreversible, giving you C. So this one is occurring in one direction. What does that mean? It means once the reactants and the product reacted and form C, C cannot be converted back to A or B. Reversible reaction, it means, let's say you have got this reaction, and this one we said is irreversible. Then we have got reversible. Reversible, it means you are having A, this reaction gives you B, and this one is a reversible reaction. This indicates a reversible reaction. What does that mean? It forms C. What does that mean? It means C can be converted back to A and B. So this reaction can only occur in a closed system. And if this is occurring in a closed system, you have got what we call equilibrium. So the definition of a chemical equilibrium says the rate of the forward reaction is equal to the rate of the reverse reaction. So when that happens, you have got what we call a chemical equilibrium. The system, I have already explained. In the reaction, we have got different types of reaction. In this chapter, which is the chemical equilibrium, you must be very careful, because in order for you to write the Kc expression, the type of reaction will play an important role, like a homogeneous reaction. What is a homogeneous reaction? A homogeneous reaction, in grade 10, you have done the state of matter, when you have done the liquid phase, the solid phase, and also the gaseous phase. So if both A is in gaseous phase and the product is in gaseous phase, this type of reaction is called a homogeneous reaction. What does that mean? It means both the reactants and the product are in the same phase. Then we have got what we call a heterogeneous. If I change A or let me write it in the next page. If I have got A, and this is in a gaseous phase, and I've got B, and B is in the liquid phase, and this gives C, which is a solid. What are we having here? We are having a heterogeneous reaction. Why? How do we define a heterogeneous reaction? Because the reactants and the product are in a different phase. So when you are going to write the Kc expression, the most important thing that you have to look for, you have to look at the type of reaction, because certain phases are not supposed to be written when you write your Kc expression. Now, let's start with how to write the Kc expression, which we call it Kc. We refer to it as Kc, equilibrium constant. Let's take, for instance, you have got that reaction, which is N giving you A plus M giving you B. It's a dynamic equilibrium giving you X plus Y D. Now, let's look at this reaction. This reaction, we have got our reaction. You have got A, you have got B. This gives you C plus D. And you are expected to write the Kc reaction. How do you write your Kc expression? Kc expression is given by the concentration. This bar stands for the concentration of, this is your product, the concentration of C. Look at how I'm writing C, and the number of moles become the exponent. 2 giving you Y, you don't add or you don't write the plus sign or the multiple sign, so you multiply by D, the same thing that I've done, giving rise, your exponent become, your number of moles become exponent. This will be divided by your reactants, which is A. Same thing, the number of moles become the exponent, which is N, multiplied by B, and the number of moles become exponent. Grade 12, very careful. Don't start by saying Kc is equal to the concentration of the product divided by the concentration of reactants. We normally do it as teachers in order to explain to you to get the correct expression. But over the years, we have realized that learners will start by writing Kc is the concentration of the product divided by the concentration of the reactants and leave it there and lose the marks. So it is very important for you to write Kc the correct way. The concentration, C and D are your product. The number of moles of C is Y. The number of moles of C is X. The number of moles of Y is of D is Y. The number of moles of A is N, and the number of moles of B. So what do we have here? C and D are your product, and A and B are your reactants, and the number of moles become the exponent. That is how you are going to calculate the Kc expression. And in order for you to write the Kc expression, because Kc expression includes the number of moles, so in other words, your chemical reaction must be balanced. It's very important. If your chemical reaction is not balanced, you are not going to write the correct Kc expression. And what I've written my Kc expression, my equation here, it can also lead to confusion because I didn't include the phases. In writing your Kc expression, the concentration of the liquid and the concentration of the reactants is regarded as constant and equal to 1. What does that mean? It means when you write your Kc expression, you don't include those products that are in a solid phase, those reactants that are in a solid phase. Only gaseous phase and aqueous solution are the one that you must indicate when you write your Kc expression. Let us define chemical equilibrium. Like I've defined it for you. I'm just defining it so that you can always be in an examination, don't make mistake. chemical equilibrium, we said, is the rate of forward reaction is equal to the rate of reverse reaction. You leave the word rate in the examination, you don't get the marks. You leave the word equal, you don't get the marks. It is very important to write it the way it appears on the examination guideline, and the examination guideline define it as the rate of the forward reaction is equal to the rate of the reverse reaction. Now, what you have to know is that a reaction is dynamic. If the reaction is dynamic, it means it doesn't stop. It keeps on, because the reactants will be converted to the product, and the product will be converted to the reactants. Now, let us look at this reaction. If you have got the reaction of H2 in a gaseous phase, it gives you I. It gives you I in a gaseous phase. This gives you 2HI in a gaseous phase. What are we having here? We are having a homogeneous reaction. What do we mean by homogeneous? Both the reactants and the product are in the same phase. And you have got I2, you have got I1. Don't make mistake of writing this 2. Hydrogen gas is a diatomic gas. Every time when you write hydrogen, it must always have got a 2 to indicate that it's a diatomic gas. So the mistake that learners do, they confuse this 2 with this 2. This one is because hydrogen gas is a diatomic gas. This 2, it indicates the number of moles. So how are you going to write the Kc expression? It's very important. First, the equation is balanced. That is number 1. Number 2, you look at the phases. The phases, they are all in a gaseous phase. And we have indicated to you that when you write the Kc expression, your Kc expression only include the gases and the aqueous. The rest, the liquid and the solids, you don't include that when you write the Kc expression. What happened when you're supposed to write the Kc expression? In this case, your Kc will be given by, this is your product, the bar. Don't use any brackets. You must use the square brackets. That indicates concentration of hydrogen iodide. What? We said the number of moles become the exponent. And then the reactants, H2. Remember, I'm not including the phases. The phases are not included in the Kc expression. And iodine. Once you have done that in an examination, you got yourself a mark. You have written a Kc expression. And once you have done this, the rest, when you do the calculation, will follow. Now, let's now put it in the form of the graph. When we were doing the rates of reaction, I explained to you that when we start in the reaction, we don't have got the reactants. We don't have got the product, we have got the reactants. In this case, this is your forward reaction. This is your forward reaction. And from this side, when it goes there, is your reverse reaction. Not reversible reaction, a reverse reaction. What happened? We start with the maximum amount of the reactants. And as the reaction proceeds, then it becomes flat. Then this is your reverse, where I start from HI. HI now is your reactants. But remember, we said to you, the product always starts at 0. That is why this graph, the two graphs are starting at different positions. This is your forward reaction, and this is your reverse reaction. When you start at 0. I want you to look at this point. This point is where the equilibrium has been reached. And in that point, we call it chemical equilibrium. That is when the rate of the forward reaction and the rate of the reverse reaction are equal. And as soon as they are equal, what happened? The line becomes flat. What does that mean? It means at this point, equilibrium has been reached. So, and only equilibrium can be reached when you have, when this reaction is occurring in a closed system. In an examination, examiners can just give you and say to you which one is the forward reaction, which graph is represented by the forward reaction, and which graph is represented by the dotted line. In the exam, they normally use different lines in order to separate the two. But what is important when you answer is to be able to know which one are the product and which one are the reactants, and automatically we start with the reactants and we end with the product. If now I reverse this reaction, what I'm going to do, it means now your 2HI become the reactants, and this gives you H2, which is a gas, plus I2 in a gaseous phase. What did I do? I just reversed the reaction. So what happens? This becomes the reactants, and this becomes the product. That is where learners make a mistake, because every time when we give example, we always say A plus B gives you Y. There's no time that we said we are going to have got D, and the D will give you A plus B. So in this case, what is important to write the Casey expression is to be able to know what do you have on the left-hand side and what do you have on the right-hand side. Whatever you have on the left-hand side become your reactants. What you have on the right-hand side become your product. I hope you are not going to make a mistake. And it is not always A plus B that gives you C. Sometimes you can have got A plus B give you C plus D. So the number of the product and the number of reactants are determined by your reactants, which is going to give rise to the product. What are the conditions? I always tell you that I also told you in the beginning, in order for the equilibrium to reach, the reaction must be reversible. Reversible, it means there must be a forward and there must be a reverse reaction. And it must be in a closed system. If it is not in the closed system, an equilibrium will not be reached. The definition I've explained to you, and you can also define the rates, the chemical equilibrium as the stage at which the concentration of both the reactants and the product remains constant. In the graph, at this stage, it is where a chemical equilibrium has been reached. What are you seeing here? You are seeing that the concentration of the reactants and the concentration of the product are constant. What does that mean, constant? It means they're not changing. They remain the same. So at that point is when we said we have reached a chemical equilibrium, and this can only occur in a closed system. If this reaction is now in equilibrium, then you can be able to write the equilibrium constant. So these things are following this sequence. First, it must be in a closed system. The second one, it means that the reaction must be reversible. If I don't have got, let's say for instance, I don't have got this part, and I only have got the forward reaction, and we said you cannot write the Casey expression. In order for the Casey expression to be written, you need to have got what we call a dynamic equilibrium. Dynamic means it must be a reversible reaction. Now, that is how I've indicated to you how we write the Casey expression, and this is the concentration. You know, I explained to you that the concentration must be in mole per decimeter cube. That is the unit for writing the unit of the Kc. Now, let us do an example, some activities quickly. Let's look at this reaction. You have got calcium carbonate, which is in a solid phase. And it gives you calcium oxide, which is also in a solid phase, plus carbon dioxide in a gaseous phase. This is a very interesting equation. What are we having? To start with, the reaction is homogeneous, it's heterogeneous. Solid, solid, gas, they're in a different phase. The reaction, number 2, is balanced. Number 3, is reversible. So it meets the condition in order for us to write the Casey expression. How do we write? I indicated to you that the concentration of the solid is equal to concentration of the liquid, and this is equal to 1. So in your Kc expression, you don't include solid. Grade 12, when you write your Kc expression, solids and liquid, they're equal to 1. You are doing mathematics. Anything that is multiplied by 1, it remains the same. So how do you write your Kc expression? Your Kc expression in this case, which ones are the product, which ones are the reactants? You have got calcium carbonate. It gives rise to calcium oxide plus carbon dioxide. What are you having as your product? Your product is calcium oxide plus carbon dioxide. And because this is 1, what are you going to remain with? This is solid, is 1. This is 1. What do you remain with? You remain with carbon dioxide, which is going to give you S. Kc will be equal to the bar of CO2. What is the number of mole? The number of mole is 1. If you want, you can include 1, divide by 1. But I know you are smart, grade 12. I know you are smart, grade 12. You know very well anything multiplied by 1, this gives you CO2 as your Kc expression. Let's go to number 2. Your number 2, you have hydrochloric acid or hydrogen chloride gas. This gives you water in a liquid phase. This gives you H3O plus in an aqueous phase, AQ plus Cl chloride in an aqueous phase. Same, this is a heterogeneous reaction. These are your product, and these are, I wonder what happened here, HCl plus H2O, giving you H3O plus aqueous plus Cl minus aqueous. When you were doing the acids and base, and when they were indicating the conjugate acid-base pair, this is one of the examples to indicate acids and base reaction. Like I said, these are the reactants, and these are the product. And when you write your Kc expression is given by the concentration of your product plus, because it's in aqueous phase. If it is in aqueous phase, it forms part of the Kc expression multiplied by Cl minus, because it's an aqueous, is part of the expression. But in this case, you have got gas, you have got liquid. I told you that the concentration of the liquids is 1. So this will be given by HCl in a gaseous phase. And we have removed, we don't include water because water is in a liquid phase. I indicated when we were doing the objective that the value of Kc tells you is very important, and you must be able to interpret it in the examination. What does Kc greater than 0, greater than 1 mean? Kc greater than 1, it means you have got more product than reactants. What does that mean? It means if your product is 4 and your reactants is 2. And what does that mean? By meaning that the product are more, it means the forward reaction has been favored, which is the word that we are going to use when we explain the equilibrium, the position of the equilibrium, So what is going to happen here is that when you divide 4 by 2, you are going to have got a value that is greater than 1, and that means your Kc your forward reaction has been favored. What is Kc less than 1? Kc less than 1 means you have got more. So in other words, this one is now 2, and this one is now 4. And if you have got this, what is going to happen? It means your Kc will be greater than 1. And also in the exam, it is only one factor that affects Kc, and that factor is temperature. So all the other factors doesn't affect Kc. Kc is only affected by temperature. And if Kc is greater than 1, the forward reaction has been favored. Kc less than 1, the reverse reaction has been favored. And this was in your last year's, in the last year, the learners that wrote the 2019 exam, this question was there in both the multiple choice question and also in the long question. Now, let's start with the what do we do when we calculate, how to calculate the Kc expression. I told you, Kc doesn't have got a formula. The formula, you write it yourself. Where do you get the formula? Your formula, you get it from the Kc expression. Let us look at this example, which is very quick and very simple. An equilibrium of a mixture of carbon dioxide, hydrogen, carbon monoxide, they are all in a gaseous phase. This is the reaction. Both are in a gaseous phase. So because they are in a gaseous phase, we have got a homogeneous reaction. Number two, the reaction is balanced. What do we mean? The number of carbon, the number of hydrogen are equal. The number of oxygen, the number of oxygen are equal. So everything is balanced. It's at 0 degrees Celsius. It's analyzed. And what was found? We was found that the concentration of CO and the concentration, this one, grade 12, is the easy one to start with. In the exam, don't expect to find something simpler as this one. We can't give you 9 marks for a simple exercise like this. But why did I give you this? I give you this one as a starting point. How do we mark you? By writing your correct Kc expression, we give you a mark. By writing the concentration by substituting, you get a mark. What did you do? You substitute 3, which is the concentration of CO. You substitute 707.2, which is the concentration of water. You substitute carbon dioxide, which is the concentration of carbon dioxide, and you multiply. Use grade 12. Important. Don't use your mental calculation. Use your calculator all the time when you calculate. So this is the answer. This is very simple. It's a straightforward, something that you can start with when you are at home. Let's move. This one, grade 12, this is part of the question that you expect in the examination. Let's analyze this question. You have got 3 moles of hydrogen. This 0.32 mole, and this react with 0.2 mole of oxygen, and this is placed in the container. And the volume, that is before the equilibrium has been reached. What happened when equilibrium has been reached? When equilibrium has been reached at 500, what did we do here? We increase the volume of the container. And what was found? It was found that there was 0.1 mole of H2. What are we having here? We're having 2 H2 in a gaseous phase, and this gives you oxygen. In a gaseous phase, this one must give you 2 H2O in a gaseous phase. What are we starting with? We're starting with 0.3 mole of H2. We are having 0.2 mole of oxygen. And what do we have? Like I indicated to you, when we start, we don't start with the product. When you are cooking pap, you start with the water and the millimil. You don't have got pap. The same thing. It means the product, you don't have got the product. And what are they telling us? They're telling that when equilibrium has been reached, what are we having? We are having 0.1 mole of H2. And they say to you, calculate the Kc. Now, the method that we normally use, we use what we call the table method. I didn't use the abbreviation because in the examination, when you use the abbreviation, you don't get the marks. What is the ratio? They are reacting in a ratio 1:2:1:2. What is it that we have given? we were given 0,3 and 0,2. Initially, like I indicated, you have got 0. What happened? This one, in the examination, we don't give you for telling us 2 is to 1 is to 2, because you haven't done anything. You just copy it from the formula. What we do, we have used the ratio. How do we use the ratio? We have just multiplied the ratio by x. That is where you start scoring a mark. You have used the ratio. But what do we have? We were told that we have got 0,1, which was left. What is the ratio? If this is 0,1, it means this one is going to be 0,1, because they're reacting in a ratio 1 is to 1. But this one is ratio 1. What does that mean? It means for this one, we must now divide it by 2 to get it a half. So what are we having here? You must subtract. You start with 0,3. What was used up? Like the ratio. You have remained with 2. This method, I like it because you don't have to use mathematics a lot. You just multiply what remained with 0,1. And this gives you 0,2. This one is your x. Dividing 0,2 by 2, you get 0,1. And this one will be the same as 0,1, 0,1. And because it's in a ratio 2 is 2x, then you get it as 0,2. Concentration. Remember, there's in the question they said the volume was 500 cubic centimeter. So what do? Because the unit for concentration is in mole per decimeter cube, we divide this by 1,000. Once we divide this by 1,000, we are going to have got, how do we calculate number of moles? How do we calculate concentration? Concentration is given by the formula N over V. What do we have here? We have a 0,1, which is the number of moles at equilibrium, divided by 0,2, and this gives you 0,5. The same applies. Then you have got the concentration. Once you have got this concentration, then you can write your Kc expression. How is my Kc expression? From the equation, my Kc expression will be equal to H2O squared divided by H2 squared multiplied by O. Then, what am I going to do? I'm going to take the values that I've calculated. I'm going to take these values, which is 1 divided by 0,5. Then you can use these brackets. Squared multiplied by 0,5. And you get your answer using the calculator. Another example, which we are going to write it first because of time. This one, I'm not going to give you the answer. I want you to work through it and get the answer. Once you get the answer, compare. When you are alone, compare it and get the answer. So that is how we calculate the Kc. There are many ways that the examiner can ask you. In some cases, the examiner can give you the number of moles. Then from the number of moles, it's easy. But in some cases, the examiner can give you grams, where you're supposed to calculate number of moles. Once you have got the number of moles, then you have got the answer. That is the calculation. Now, let's do the last concept, which is the Liturginous Principle. I said to you, you need to state the Liturginous Principle. Last year, it was in a question paper. How do we state the Liturginous Principle? When the equilibrium in a closed system is disturbed, the system will reinstate, And once it has reinstated, a new equilibrium is going to be reached. Or if any condition in an equilibrium system is changed, the equilibrium will favor, don't use the word shift, will favor the direction which will oppose the change. What are the factors that affect the rates of reaction, the chemical equilibrium? Number one is concentration. How does the concentration affect the reaction? Let's take, for instance, you have got this reaction. Let's use the Haber process, where nitrogen in a gaseous phase react with hydrogen in a gaseous phase. This, in a dynamic equilibrium, give you NH3 in a gaseous phase. To balance it, this will be 2, and this will be 3. Factor number one, concentration. What happens when you increase the concentration of N2? When the concentration of N2 is increased, what will happen to maintain the equilibrium? It means the H2 must decrease. Once the H2 has increased, it means the forward reaction has been favored, which means you are going to have got more of NH3. So this is concentration. What happened now? This is the summary. If I increase the reactants of the concentration, if I increase the concentration of the reactants, what happened? The forward reaction is favored. If I increase the concentration of the product, what will happen? The forward reaction is increased. But let us look at temperature. I want us to spend more time on temperature. Let's look the same reaction. I have now indicated something that we haven't talked about, which is delta H less than 0. What does that mean? It means this is an exothermic reaction. Because your delta H is less than 0, what is happening is that energy is released on the system. So according to Liturginous Principle, an increase in temperature, if the temperature is increased, what happens when we add temperature? When we add temperature, what happens when I increase temperature? An increase in temperature will favor the reaction that absorbs energy from the surrounding. What does that mean? It means when you increase temperature, an endothermic reaction is favored. Let us look at this reaction. We said we have got the reverse reaction, and we have got the forward reaction, and we have got the reverse reaction. What is happening here is that if I increase temperature, when I go this way, this one is an exothermic reaction. So your reverse reaction, this one, is an exothermic. And this one is an endo. What does that mean? It means if the temperature is increased, it will never favor the exothermic reaction. What does that mean? It means you're not going to have got more product. You are going to have got less product because that reaction is not favored. Which reaction is going to be favored? The reaction that is going to be favored is the reverse reaction. Why? Because the reverse reaction is the reaction that absorbs the energy from the surrounding. Let's take, for instance, I gave you a bucket. And in the bucket, I have got holes and say to you, go and fill the bucket. Will the bucket going to be filled? No. Why is the bucket going to be filled? Because what you are putting inside the bucket is not absorbed by the system, it's wasted by the surrounding. What happened? What the examiner can say, what happened, what must be done in this reaction in order to have got more product? What must you do? You must decrease the temperature, because when you decrease the temperature, a decrease in temperature favors the exothermic reaction. Concentration, I've indicated to you that let's look at this reaction. If I increase, if this one goes up and this one goes down, what happens is that the reaction will increase and your HI will be favored. Catalyst. We have done catalyst when we were doing the rate of reaction. What happened with catalyst? Catalyst will not, I repeat, catalyst will not increase or will not shift the equilibrium position. Why? Because catalysts only increase both the forward and the reverse reaction. And if both the forward and the reverse reaction are increased at the same time, it means no reaction will be favored and no reaction will increase or decrease. This is the summary of what I've been doing. I urge you, grade 12, to write this summary in your books. And grade 12, thank you so much. This is your chemical equilibrium, which is your question 2, question 6, that you're going to find in your paper 2 chemistry. Good luck as you continue studying at home. Thank you so much.